Let's continue talking about how we can use Desmos to help us graph. A pension fund manager decides to invest a total of at most $30 million in U.S. Treasury bonds, paying 4% annual interest, and in mutual funds paying 8% annual interest. He plans to invest at least $5 million in bonds and at least $10 million in mutual funds. Bonds have an initial fee of $100 per $100 million, while the fee for mutual funds is $200 per million. The fund manager is allowed to spend no more than $5,000 on fees. How much should be invested in each to maximize annual interest? And what is the maximum annual interest? So I know that I want to maximize, so I'm going to use my Z function here. Remembering that we use percent, we change to a decimal. So I'm going to associate X being for the X to represent the U.S. Treasury bonds, and therefore Y would be the mutual funds. And then we're going to use that same pattern throughout. So I'm going to set up a little table here. We have bonds and mutual funds, bonds representing again X, and mutual funds therefore representing Y. So I know that when I add them together, because it says from the first sentence, decides to invest a total of at most $30 million in two different bonds. So the X bond and plus the Y mutual fund has to be less than or equal to 30 because we don't want any more than 30 million. We know that he wants to spend at least 5 million in bonds. So our bonds has to be greater than 5. Therefore, and at least 10 million in mutual funds. So Y would need to be greater than or equal to 10. We also have some fees that we need to take into consideration. So we have 100 per million in bonds, so 100 times how many bonds we have, plus 200 times how many ever mutual funds we have. It says that they can spend no more than 5,000 on these fees. So this has to be greater than or equal to 5,000. Further, we know that bonds and mutual funds cannot be less than 0. We cannot have -4 bonds or -4 mutual funds. So we're going to say that our bonds have to be greater than or equal to 0, and our Y value has to be greater than or equal to 0 as well. So it's limiting our graph to the first quadrant. So let's graph these so we can identify the location where we might be able to maximize this value now that we have our equations. So our first equation to graph is X plus Y is less than or equal to 30. On our next line, we have X is greater than or equal to 5. We also have Y is greater than or equal to 10. And we also have 100X plus 200Y has to be greater than 5,000. I know that we're in the first quadrant, but I can't quite see everything. So I'm first just going to move this to the first quadrant. Can I move it down so I'm focused just on one area here? And I'm starting to see a line up in this corner, so I'm just going to zoom out a little so I can start to see where my graphs might overlap themselves here. To help better see our area, it might be useful to stop the shading so you can kind of work one to the next. So if we start with X plus Y is less than or equal to 30, here's our shading for this one. When I build the X is greater than or equal to 5 on top, then I have this triangular region here. So just looking at this triangular region, what happens when we add in the next one? So when I add in the next one, notice that our shading becomes these this triangular region here. But now we have this one last one that we need to also include. So kind of think about where that triangle is, and when we add this one in, we now have a new region. So our new region contains these 4 points that are listed here. So now we can identify which one of these 4 points will maximize our region here, our feasible region. Now that we've graphed it and found our points, let's finish it off so we can identify and answer the questions to maximize our z function. Here is our graph with our 4 points that we had from the Desmos. So we need to plug them in. So if I start on the top left point with the point 5, 22.5, I'll plug each one respectively in for x and y, and I see that I end up with 2. Plugging in 1020, I end up with 2 as well. Plugging in 2010, I end up with 1.6. And when I plug in the 0.510, I end up with the value of 1. Notice here that we have 2 different options for the maximum value. The maximum annual interest earned is in $2 million because we're in millions as it states above in the problem. So that answers the question, what is the maximum annual interest rate? And then it asks how much should be invested in each so that we can earn that maximum interest. So when there is $5 million invested in bonds and $22.5 million invested in mutual funds, or because there are 2 of them, we have a second option. When there is $10 million invested in bonds and $20 million invested in mutual funds. An insurance company is considering 2 insurance plans with the types of coverage and premiums shown in the table. We have 2 policies with fire and theft liability and then their premium. The company wants at least $300,000 in fire theft insurance and at least $3 million in liability insurance from these plans. How many units should be purchased from each plan to minimize the cost of the premiums? And what is the minimum premium? So we want to minimize our z function. We want to minimize our premium. So $50 times how many ever units of Part A and plus $40 how many ever units of Policy B. So we need to know what we need to graph. The first sentence tells us the company wants at least $300,000 in fire and theft. So when I take 10,000 times how many of units A plus 15,000 times the units of Y for policy B, that must be greater than or equal to 300,000 because that we want at least that much. So we want more than 300,000. And they also want at least 3 million in liability insurance. So 180,000 X plus 120,000 Y must be greater than or equal to 3 million. Okay. Also, because we can't have negative policies, we're going to restrict our graph to be in the first quadrant, just like the last example. So let's take a moment to graph this over in Desmos and see what we come up with. All right, our first equation was 10,000 X plus 15,000 Y had to be greater than or equal to 300,000. Our next equation was 180,000 times X, 120,000 times Y had to be greater than or equal to 3 million. And of course, we are on the first quadrant. So I'm going to pull this over. Okay, I'm starting to see my graph a little bit, but I need to expand so I can see a little bit more. So it looks like where we are crossing for our feasible region would be these 3 points here that we have to check with our z function. So let's take a moment to check them. Transferring our graph over with our 3 points, we want to minimize the z function $50 times policy A plus $40 times policy B for how many ever units we purchase. So starting on the top left, if I take the point 0.25 and plug in 0 for X and 25 in for Y, I see that my premium would be $1,000. Moving down a point, I have 616. I see that when I plug those in, my policy is $940. And finally, plugging in the 0.30, I end up with $1,500. That would be a maximum value in this instance, but I see that our premium minimum is $940, and this occurs when there are 6 units purchased from policy A and 16 units purchased from policy B. So that answers part A. Part B says, suppose the premium for policy A is reduced to $25. Now how many units should be purchased from each plan to minimize the cost of the premiums, and what is that minimum premium? So all I'm doing is changing this $50 into 25. So my Z function is going to change to 25x plus 40y. So everything with our Z function, plugging them in, the only thing we need to change and reconfigure is the first part, the 25 part. When I replug them in, using 25 instead of 50, I see that my new premium minimum is $750. And that occurs when there are 30 units purchased from policy A and 0 units purchased from policy B. It is slightly less than what our minimum was when our premium was $50. So although it seems like a large change, it certainly does make a difference. I hope using Desmos will help you with this lesson, at least visually see a little bit more easily, and at least see where the points of intersection are more clearly when it comes to graphing.